AET 114, Chapter 24, Problem 3. It says repeat problem 1 if each phase impedance is changed to a 10 ohm resistor in parallel with a 10 ohm capacitive reactance. So the circuit basically looks like this, only what we have is right here. Problem 1 is, it just says a balanced Y load having a 10 ohm resistance in each leg is connected to a 3-phase 4-wire Y connected generator having line voltage of 208. So the line voltage would be, say, from here to here, which is going to be 208. From here to here and here to here, it's going to be 120 as shown. So it says calculate the magnitude of the phase voltage of the generator. We're looking at this. So what we would have is a 10 ohm resistor in parallel with a 10 ohm reactance of a capacitor, all right, instead of these 20 ohm resistors. So if we go back to that problem, E is looking for the phase voltage, and that's going to be 120 volts, and then the the phase voltage of the load, that was the phase voltage in generator. Phase voltage of the load is going to be the same because they're both Y connected. And then part C, it's asking for the phase current of the load. So the first thing you have to do is figure out the phase impedance, which is going to be a 10 ohm resistor in parallel with a 10 ohm capacitor, which equals 7.07 ohms angle -45. And then you take the phase current, which is the phase voltage divided by the phase impedance, 16.98 ohms or amps. So what I did to take this further was I took this capacitor and figured out I picked 60 hertz just off the top of my head. This is going to be ohms, and then this is going to be in farads. This is in volts. All these are in volts. So what I did was I picked a frequency, 60 hertz, and then I also this is the line-to-line voltage here, and this is the line to ground voltage, and then the peak amplitude line to ground voltage is about 170. So I did this problem in every circuit, and here it is. So again, so you have, I calculated this resistance based on that 60 hertz frequency, and I have my Y connected 3-phase, and then you could see that this is the voltage going across this generator here. And then I'm going to turn this on and show you the other two voltages, okay? So then we had to calculate, which are also the voltages across the load because they're in parallel. So you had to calculate the current. So we're going to turn these off and look at the current. This is just, I only put one current in there. And that current is 24 amps. 24 divided by the square root of 2 is going to be about 17. So that's it for problem 3.